we're going to talk about polyatomic ions. Poly is a prefix that means more than one, so these are ions, species with a positive or negative charge, that have more than one atom in them. And you're just going to have to memorize these. That's all there is to it. In order to name the compounds that they're going to be in, you've got to know these, and you can't be spending time going up, looking up what they are. You've just got to memorize them. In terms of polyatomic cations, there's ammonium. And that's it. NH4+. Now don't confuse it with the compound NH3 ammonia. That's the compound. But NH4+ is ammonium. It's where you got a nitrogen that's covalently bonded to 4 hydrogens. It's lost an electron to give it a positive charge, and that becomes the ammonium ion. Memorize it. Now come a whole mess of polyatomic anions. So these are all going to have a negative charge. Hydroxide is OH minus. It's an oxygen and hydrogen covalently bonded together. We've added an electron to give it a negative charge. So that's OH minus. Acetate is C2H3O2 minus. Acetate. Cyanide, bad stuff, you want to stay away from it, is Cn minus. And so those are sort of 3 standalone polyatomic ions that you need to memorize. And then there's a number of oxo anions. Oxo gives me a hint, or gives us a hint, that they contain oxygen. The first one we'll look at is carbonate. CO3 2 minus. Carbon, 3 oxygens, and a -2 charge. If you notice when we write this -2 charge, we don't write it as CO3 -2. It's CO3 2 minus. It's got a first cousin that's called bicarbonate. That's HCO3 minus. So the carbonate CO3 minus and bicarbonate HCO3 minus. You may have heard of Na2CO3 sodium carbonate and NaHCO3 sodium bicarbonate. They're common household chemicals. Memorize those. And then there's a number of oxo anions that are going to have a very similar type of way of going about naming them, and it can be confusing. So it's real important that you get these and understand what these are. Now let's look at some other oxo anions. And let's look at some that contain sulfur. So this SO4 2 minus. This is sulfate versus SO3 2 minus. That's sulfite. Sulfate and sulfite. And just a comparison, not to confuse, but to try to prevent confusion. Sulfur by itself with a -2 charge is sulfide. So you got sulfate, sulfite, and sulfide. You've got to be able to discriminate against these. You've got to memorize them. You want to see a pattern get generated now. let's look at 3 ions that contain nitrogen. NO3 minus, NO2 minus, N3 minus. The first one is nitrate. The second one is nitrite. And the last one is just a monatomic ion, and it's nitride. Nitrate, nitrite, and nitride. So, where the confusion comes in is we got 8 sulfate and nitrate, but they don't have the same number of oxygens in them. They don't have the same charges. We got 8 between sulfite and nitrite. Different number of oxygens, different number of charges. 8 and 8. What do those refer to? Well, 8, when you have just 2 of a compound that have oxo ions, the one with the more oxygens in it is the 8. The one with the lesser number of oxygens is the 8. So SO4 2 minus has the extra oxygen compared to the SO3 2 minus, so it's the sulfate versus sulfite. Likewise for nitrate and nitrite, nitrate has that extra oxygen in it. PO4 3 minus, PO3 3 minus, and P3 minus. Following this trend that we've seen before, they become phosphate, phosphite, and phosphide. Make sure you know the differences. So far, so good. Got to memorize these. And now is going to come the last group of these oxo ions that we're going to talk about. There are many more, but this is what I'm going to limit our discussion to. There's a set of chlorine-containing oxo polyatomic ions. ClO4, ClO3, ClO2, and ClO minus. All these have a -1 charge. They have different number of oxygens. And so before we've just had a pair of oxo ions for the sulfur, the nitrogen, or the phosphorus. Now we actually got 4 of them. ClO3 minus is going to be our 8 containing ion, chlorate. And the one that's lesser than that is chlorite. And so, but now we've got extra ones in the family. And so the one that has the maximum amount, when you got a series that actually has 4 different oxygens in it, becomes perchlorate. Perchlorate, where not only have you added the suffix ate, as we have used before, we're now adding a prefix of per. ClO minus is going to become hypochlorite. Hypochlorite, where we're using the prefix hypo and the suffix ite. And so this corresponds when you've got a series of 4 oxygens in a family of oxo ions. The one with the most is per 8. The next most is 8. The next one is ite. And the one with the least number of oxygens is hypoite. You'll see similar types of compounds if you did this with bromine or iodine. You need to have periodate, iodate, iodite, and hypoiodite for IO4 minus, IO3 minus, IO2 minus, and IO minus. So these are some polyatomic ions. You just got to memorize these. So let's do some practicing. Let's look at these four compounds. The first one, you've got to recognize that it's a metal plus a polyatomic ion. That it's not some sort of lithium sulfur oxide compound. Not going to name it lithium sulfur tetroxide, for example. You've got to recognize that the SO4 is a polyatomic ion. And it's lithium sulfate. We've memorized the sulfate. The sulfate has a -2 charge, hence the lithium. We needed 2 of those, each with +1s. This is a group 1A alkali metal to give it an overall negative charge. Now we got 4 different iron compounds. These all have Fe in them. They're all iron. And iron is a transition metal, so it can have a variety of oxidation numbers. And so we got to figure out what the oxidation number is of iron in each of these. Well, NO3 is nitrate. We've memorized that nitrate's got a -1 charge. We got 3 of them. So we got 3 times -1, so all of our nitrates add up to -3. To make this electrically neutral, this iron has to be +3 in this instance. So this is iron 3 nitrate. Remember our stock nomenclature in that we're going to put the charge of the metal as a Roman numeral in parentheses. Next one's not iron nitrate, but it's iron nitrite. Which one is it? Once again, nitrite, it's got a -1 charge. We got 3 of those, so this is iron 3 nitrite. We now compare these with the next 2 compounds, which once again, respectively, are some sort of nitrate and nitrite, iron nitrate and iron nitrite. But which one are they? This first one that we're looking at, each nitrate is -1. We've got 2 of those. Altogether they add -2. To make this electrically neutral, that single iron has to be +2. So that's iron 2 nitrate. Likewise, the next one, nitrite, still a -1 charge. We've got 2 of those. The nitrites altogether add up -2. The iron has to be +2. So it's going to be iron 2 nitrite. These just take lots and lots of practice. So we've done some that are, we've been given the formula, we need to come up with a name. Now let's do a few that if we're given the name, we got to come up with the correct formula. So calcium hydroxide. Calcium, if you look at a periodic table, it's in group 2A. It's an alkaline earth. it gets a +2 charge when it forms an ion. Hydroxide is a polyatomic ion. It's OH minus. So if we write the formula, it's going to be calcium. OH, but how many OHs do we need to balance this electrically, to make it neutral? We need 2 of them. So it's going to be Ca, open parenthesis, OH, close parenthesis, 2, calcium hydroxide. Ammonium nitrate. Ammonium is something that we've memorized to be NH4+, and nitrate, which we've been doing up above, is NO3-, so ammonium nitrate, NH4, NO3. That's a common compound that's found in fertilizer and explosives for that matter. Manganese 4 sulfate. Manganese, the symbol for manganese is Mn. And what we're told here is that it's got a +4 charge. So sulfate is SO4 2-. So to make things balance out, sum of the positives has to equal the sum of the negatives. So it's going to take 2 sulfurs to balance out that manganese. So we're going to put a parenthesis around the sulfate and put a 2 out there as a subscript. So it's manganese sulfate, manganese 4 sulfate.